So today I will be focusing on Riemann sum, specifically RRAM and LRAM. So in order to find an area under a curve, a simple way to do it is by making rectangles. So consider the following function. F of x equals x squared plus 1. The function looks like this. In order to find the area, like I said before, you make rectangles like this. Like just rectangles on every single one. And this works because, as you could tell, as you know from geometry, an area of a rectangle is base times height. So the function we're looking for delta x, which is the base, so a change of x, and your y value, which is your height. So it works out. In these problems, they should give you boundaries in order to find the area between them. And they also should give you rectangles, like how many you need to solve the problem. And in this problem, it says approximate the area under the curve for f of x, which equals x squared plus 1, between 0 and 2. So your boundaries are 0 to 2, using 4 approximate rectangles. And I'll get to this part, this little star, a little later. So the formula we need in order to solve this is this scary little fella over here. I'll break it down to you right now. So let's start with this fella. B, that equals the second point given. So that's your second boundary. A equals your first point given. N equals the amount, so a number of rectangles given. Well, how many rectangles you need. And then let's talk about this little fella. This is your delta x, which is your base. And this is your f of x, which is your y, which is also known as your height. So let's start off with this fella. So f of x to subinterval 1 equals the y value to the first x value of your rectangles. So it'll be this fella. Well, this fella. One of this one. I'll show you later. The rest of these are the same thing. So I'll just do the subinterval 2. It's the same thing as this, but to your second x value. And it goes on until you finish all your rectangles. So this one will have 4 subintervals. So it's going to be f of x the first, second, third, fourth. So f of x to the nth means your y value to the final x value that you have. That's all it means. That's why there's dots here, because it's an unlimited amount of rectangles that you could use. The more rectangles you use under the curve, the closer your area is to the actual area under the curve. Okay, so I'm gonna erase all this. I'm going to keep my formula up there. I'll get back to it later. Right now, most of these problems are going to ask you for either LRAM or RRAM. They might ask you for another one, but I'm not talking about that today. So LRAM means left rectangular area method, and RRAM means right rectangular area method. So what this basically means is to use the left for LRAM is to use the left point of your function, and then RRAM means to use the right point of your function. I'll show you that later on. Right now I'm going to show you how to find delta x. In order, and this problem we're going to use RRAM. in my second problem, I'll use LRAM for the same function. And in this problem, okay, so first we're going to find delta x, which we use this little fella right here. So as I said before, b is going to be your second bound. So it's 2 minus your first bound, which is 0, all over n, which is your rectangle, so it's 4. So that equals 2/4, which is equal to 1/2, or 0.5. So your delta x is 0.5. So every single section is gonna be spaced out 0.5. I already did this for you guys. So it's 0.5, 1, 1.5, and 2, because our bounds is from 0 to 2. And there's gonna be 4 rectangles. Okay, so I'm gonna show you how to draw the rectangles right now. We're using RRAM, so we're gonna use the right point. So this is the right point, since left and right. You make a point at 0.5, you go down, and then you go left. You do the same thing for your next point. So it's 1, down, left, down again, and then 1.5, and finally 2. So we're going to find the area of all of this. As you could tell, this is going to be an over approximation, because all of this is excess area. So more area than you need. So the area we're going to find is going to be over the actual area of this function. Okay, so now let's do the math. We could, since we already found this out, we could plug it into the formula. So it's 1/2. So it's f of x. So our first subinterval of 1 is going to be 0.5, because that's our first point. So f of 0.5 plus f of 1, because our second point is 1, plus f of 1.5, because our third point, third point is 1.5, plus f of 2, because that's our final point. So after you simplify this, you get 1/2 equals, in order to find what these are, you plug them, you do simple math and you plug them into the formula, the function that you first had, which is this fella. So it's f of 0.5 is going to be 0.5 squared plus 1, which simplified equals 1.25. And then next we do our second one, so it's f of 1 equals 1 squared plus 1, so f of 1 equals 2. F of 1.5 equals 1.5 squared plus 1, so f of 1.5 is equal to 3.25. And then finally f of 2 is equal to 2 squared plus 1, which is equal to 5. So these are our y values, or our heights. And now that we have height and base, we could find the area. So the area is r of n. Sorry, I forgot notations. R of n equals 1/2. Where's our first value? 1.25 plus 2 plus 3.25 plus 5. That simplified is equal to 1/2 times 11.5. And that simplified further is equal to 5.75. And that right there is your answer to the RRAM of the area under the curve of this function. And again, it's going to be an over approximation of the actual area. Okay, now we're going to be focusing on LRAM. So in order to do this, like I said before, you have to use the left points. In this function, since we already found delta x and I have it all set up, our first LRAM point is going to be 0 because it's on the left. So again, you do the same thing draw to the right and down. And your second point is going to be 0.5, and you do the same thing. Your third point is going to be 1, and your final point is going to be 1.5. You don't use 2 because it's LRAM. And we're going to find this area. As you could tell, this is going to be an under approximation because all of this is going to be missing. Okay, so we already found this earlier. And again, that's 1/2. So area equals 1/2 f of x to subinterval 1, which as you could tell is 0. So f of 0 plus f of 0.5, because that's the second one, plus f of 1 plus f of 1.5. So that's the area. Simplified, it's 1/2. Oh, sorry, before that we have to find the y values of each again. So f of 0, it's going to be f of 0 equals 0 squared plus 1. So f of 0 equals 1. F of 1.5, oh no wait, sorry. F of 0.5 is equal to 0.5 squared plus 1. So f of 0.5 is equal to 1.25. F of 1 is equal to 1 squared plus 1. So f of 1 is equal to 2. And finally, f of 1.5 is equal to 1.5 squared plus 1, which is equal to 3.25. And since we have all of our y values, or our heights, and of course our base, which is this, we can now plug in these values into our formula, which is, let me just write this down here because I didn't leave space. 2, 3.25. So I'm going to erase this. Our area is going to be 1/2 times 1 plus 1.25 plus 2 plus 3.25. And this simplified is 1/2 times 7.5. And simplified even further is 3.75. That is the answer to your LRAM of the area under the curve. And again, it's an under approximation. And you could tell, because you could also tell other than looking at the graph, because this is LRAM. And if you remember earlier, the RRAM answer was area equals 5.75, and that was over, and this is under. So the actual area is going to be between these 2 points. We don't know yet, and we can't find out using rectangles, but later on we'll find out using integrals. And that was my video on Riemann sum. Thank you for watching.